Okay, this is section 4.1, or your first section in chapter 4 on fractions, decimals, and percents. And this is the Math Links 8 questions. We're going to start at question 4. And before we start, the added learning that you're doing now in grade 8 for fractions, decimals, and percents is we want to be able to represent and think about percentages that are less than 1%, as well as thinking about percentages greater than 100%. Those are the two new learning outcomes we're going to tackle here in chapter 4. So the first question says one full grid represents 100%. So when we say one full grid, what we really mean is that right there. That is a grid. So that represents 100%, and since it's all shaded in, since there are 100 parts, we can consider that to be 100 parts out of 100. And this next part, we consider to be 12 parts out of 100. And really, since these are two separate parts, what we want to consider them being is really adding these two parts together. So 100% plus 12%. Of course, with adding fractions, we know that we keep the denominator and add our numerators. So therefore, the answer to this question, what percentage does each diagram represent? The first picture would be 112%. So really what we want to do is we want to think of it as the sum of two separate parts. In B, we have less than 1% because if this was all shaded in, we would say that's 1%. But because it's not all shaded in, it's fractionally shaded in, this is going to be less than 1%. Okay? How much less than 1%? Well, we can think of it as being how much of that 1% square is shaded in. 0.2% is what that picture is representing. Or, as a decimal, 0.2%. Now, one of the greatest things, difficulties students have is realizing that this amount here does not equal 20%, right? People look at that and say, well, 0.2 is 20%, isn't it? That's what I was always told, but it's not. This is less than 1%. So you must consider 0.2% to be less than 1%. In lowest terms, I could also express it as 0.1%. Still less than a percentage. And your last one, if we count the number of total strips, 1, 2, 3, 4, 5, 6, 7, 8 full strips, plus 1, 2, 3, 4, 5 more. So it's 85% for sure, fully shaded in. And they've magnified this one to show you that not all of it shaded in, just a third. So the answer for this one is 85 1/3%, or if you want to change that fraction to a decimal, 85.3 repeating percentages, because 1/3 as a decimal is decimal 3 repeating. Question 5 says what percent of each is represented by each diagram? Again, an entire shaded in array is 100%. So here we have less than 1% again. Here we have less than 1%. We have 3 parts out of 8 shaded in there. So it's less than 1%, and it's 0.3% is what we're going to put. Or, now, FYI, as a fraction, 1/8 is decimal 125, 2/8 would be decimal 25, 3/8 is 0.035%. Still less than 1%, because if it was, it's less than 1%, less than 1%. And we know that because it's a fraction of a percent. Our next one, this is 100%. So we're going to, as a fraction, it's going to be 100 of 100. This is going to be 25.5%, or 25.5 out of 100. So when I combine those two or add them together, I get 125.5%, or 125.5%. And down below here, the last one, I have 100 out of 100 here, 100 out of 100 here, and I have 82 out of 100 here. So if I add those all together, keeping in mind I do not add my denominators, keep my denominator, add my numerators, I get 282 out of 100, which is 282%. Question 6 asks us to represent each percent on grid. So if I think of A, 125%, I know definitively 100% would be shading in all of 1/100ths grid. So I'm going to shade that in as 100%. And if I wanted to write that in, I could write 100 out of 100. Over here, if I shaded in 25 of them, that represents 25 out of 100. So together, if I combine those two, it's 125 hundredths, which is 125%. Right? One of the confusing things for a lot of students is the denominator is not 200. We must consider 100 to be a whole, and therefore our denominator is not 200. If you are thinking the denominator is 200, what you're really considering is your, if I can move this here. Can I get this? Maybe. Maybe I can't. No, I can't. I don't think I can. Can I grab it? Oh, yes, I can. If this was the picture, this would be a denominator of 200, not 100. And our answer here would be 125 out of 100, because of the whole unit, I would have less than one full unit shaded in. But when I separate them, my denominator is just 100. For my next question, 10.5%, I'm going to shade in 10 of these. That's 10%. I'm going to circle this one. I'm going to lightly, I suppose, if I can get my highlighter here, shade in 0.5%. And what I'm going to do is I'm going to magnify over here. Actually, I'm probably not going to use this. I'm going to use a different square. So if I was to magnify that square there and shade in half of it, so if I was to magnify that, it would be like that, and this would represent 10.5%. Our next one, 0.4%. Now remember, this is less than, if I write this out, it's less than 1%, less than 1%. So when I shade it in, excuse me just a second, there we go, I have to take my highlighter, and I'm going to shade in less than it there, and I'm going to just shade it there. And if I magnify that square, I want to shade in 0.4%. So I'm going to cut this into 10 parts. 9 lines make 10 parts. I think that's 9 lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, 10 parts. And then if I shade it in, I want to shade in 0.4. So 1/10, 2/10, 3/10, 4/10, just like that. And that would represent C, 0.4%. It's less than 1%. Now your next one, D, says 262%. So we need to get, the first thing we're going to shade in is 100% of this one. And then we're going to shade 100% of the other one. So right now this picture represents 200%. And then if I shade in 6 of these, that's 260%. And 2 more is 262%. Question E says 7/8%. So again, this is less than 1% as well. Okay, both of these are less than 1%, a fraction of a percent. So I'm going to take my little yellow highlighter here, and I'm going to shade in. So when I shade it in, I'm going to almost shade in a full square, because 7/8 is pretty close to a full. And then over here, I'm going to put 7 lines to make 8 parts. 1, 2, 3, 4, 5, 6, 7. And I'm going to shade in that particular square. So then we will have 7/8 of that 1% square shaded, and this will represent 7/8 right there. And finally, our last question, 45.6%. We're going to shade in to start 45%. So I'm going to go 10, 20, 30, 40. Then 5 more percent, and that's 45%. But I have 0.6%. So I'll just use a smaller highlighter and just highlight just a little bit more than half of that square. Circle it to magnify it and bring it over here. And I want to shade in 6/10. So I'm just going to use this 100 degree here, and I'm going to shade in, oh, not that one. I want to use a bigger one. There is 6/10 or 60/100ths, right? So we could say that this is 45 and 60/100ths%, or we can just say 45 and, in lowest terms, 6/10%, right? Because we can think of this square as being 6 full parts. Going on to question 8, it says how many hundredths grids are necessary to show each of the following percents? Well, since we're dealing with 300%, we're going to take this 100%, and we would clone it 3 times. Clone it once, clone it again, So I would shade all of that in. All of those would be shaded in to represent 300%. So how many grids would I need? I'd need 3. To do 466%, this would be enough for 400%, but I need one more grid. Where's my paste? There it is there. I would need 5 grids to shade in 466% because I need to shade in all of these here, right? All of this, all of this, all of this. That's 400%, and 66% would be something like that. So 466% would require 5 grids. And for 1200%, I need to shade in exactly 1200 grids to make 1200%. Question 9, give 2 examples where a percent greater than 100% might be found in everyday life. If you play the stock market or you invest, and you invested, let's say, $20, you put $20 in, and if you got 100% of your money back after investing it, you will get all of your $20 back. That would be 100% of your money at the end of a term. You still have 100%. That means at the end of it, if you had 200% of your initial investment, then you would have, at the end of it, you'd have $40 in your bank account because you would have doubled your money, right? If you had $30 in your bank account at the end of your investing, not only do you have your 100% of your $20, but you have an additional 50%. So 150% of your money is now in your bank would be 30%. So you'd have, dealing with money, we have percentages greater than 100% all the time, especially in the stock market. Question 10 is the opposite of that. It says, why might a scientist studying water pollution work with percents less than 1? Well, if you think about a bucket of water, okay, H2O. You know that from science class, H2O is dihydrogen oxide, I think is what they call it, and water in there. But we also know that water is not just water. There's a lot of dissolved particles because you studied homogeneous mixtures and heterogeneous mixtures. And even though you can't see certain things, there's things like salts, there's minerals, and probably sometimes there's contaminants, right? So contaminants, I can't spell contaminants. So if you think about water, sometimes there's very microscopic things in there like salts that are dissolved, minerals, contaminants, etc. And since 1% of the water is not, let's say, salt, it's much, much less. Scientists use the abbreviation ppm. Does anyone know what ppm stands for? If I said 5 ppm, 5 ppm of, do you guys know NaCl? What's NaCl? Salt. So if I said 5 ppm NaCl, it was on the side of a bottle. What does ppm stand for? Does anyone know? It stands for parts per million. So out of 100 or out of a million parts of whatever it is, 1, 2, 3, 4, 5, 6, a million parts, 5 of those parts are salt. So in that water, we might say there's 5 parts out of the 1 million parts of everything that's in there is salt. Most of it, 99.999%, is water, but there are other things that are dissolved. Question 11, it says the land area of Alberta is about 113% of the land of Saskatchewan. So if I was to right-click here and paste, and I was to shade this all in right here, this would represent 100% of the land in Saskatchewan. And if this is 100% of the land in Saskatchewan, if Alberta is 113% of that, then when I put this one in, oopsie daisy, when I put this one in, I might as well just bring it over here. It's going to be all of this plus an additional, I'll just draw my own here, 13%. I'll make it up. So that's 113% of the land area. This is Saskatchewan, and this would be Alberta. Slightly more, 13% more than all of Saskatchewan. Question 12 says a 250 ml glass of milk contains 30% of the recommended daily value of calcium. Using a hundreds grid to show how many glasses of milk you would need to drink to get 100% of your daily vitamin. So if you drank, and I'll just draw it 1, 2, 9 lines, 3, 4, 5, 6, 7, 8, 9, 9 lines and shade in 3 of them. If this was a glass of milk, it would contain this percent of the amount of calcium you need. So if I was to triple this and just infinite clone it, let's group it. This would be exciting. An infinite clone. If I was to double it, I'd have 60%. If I would double it, I'd have 90%. And I don't need a full version of this. And I'm just going to, oh heavens. I don't need to triple it because really this represents 90% of my daily recommended value. And I only need one more of these, so I need a third of this one, right? So I'd need, through pictures, I would need 3 glasses and a third of a glass to make 100% of my daily calcium intake. Question 13 says, use a calculator to convert 1/3 to a decimal. So if I took this question and say, what is this as a decimal? We all know that we take our numerator and divide it by our denominator. So I take 1 and I divide it by the denominator to get 0.3 repeating, which is equal to 0.3 repeating. However, how could 1/3 be shown on a hundredths grid? So 1/3 of a percent is different. So 1/3 does not equal 1/3 of a percent. They're different altogether. This is 33.3%, and this is less than 1%. So if this full grid here represents your 100%, if it was completely filled in, 1/3 of a percent, I would have to first circle this and bring it over here. And since this is not completely shaded in, if I grab my shaded in 1/3 of that, that's 1/3 of a percent. And over here, if I magnify it, that would represent 1/3 of a percent, which is different than 33%. And it says, how are percents involving repeating decimals sometimes difficult to show on a 100 grid? It's because I can't shade in. Let me just show you a different way. So I'm going to take 2 different ways. If I was to have a hundredths grid, 33, we're going to do 33 and 1/3 percent. Okay? Or a repeating decimal, or 33.3 repeating percent. If I was to use the magnification one, I would simply take 33 of these squares, 10, 20, 30, 33, and this other one I would make a fraction, and I would circle it to magnify it, and I'd bring it over here. But when we try and magnify this to make a third, I'm having the exact same difficulty I had before. So instead of using this picture, I have to use this picture and shade it in like this. And this would represent 33 and 1/3 percent because I shade in 33 and 1/3. However, if I was just show it, instead of using a hundredths grid, I just used, instead of having 100 parts, I just have 3 parts. This same fraction can be expressed. This is 33%, 33 and 1/3 percent shaded in here. And this whole thing is 33 and 1/3 percent. So they're both the same thing. Confusing, I know. Question 14 says, if 200 squares were used instead of 100 squares to represent 100%, how would you show 0.25%? Well, this is exciting. So now our whole unit is no longer a denominator of 100. Here, our denominator is now 200 parts, okay? So how many parts out of 200 would you need to represent 0.25%? Well, if I ask the first question, how many parts out of 100 do you need to write? You would need to have 0.25 out of 100, right? That would represent this percentage, 0.25 out of 100. So what is that as an equivalent fraction out of 200? Well, in order to get that equivalent fraction, I would multiply both by 2, and therefore I would know that I need half a square out of 200. So to represent this percentage in this picture, I would simply have to take my highlighter and shade in 1/2 of 1 square out of 200, and this whole picture here now would represent 0.25%, because 1/4 of a percent is equal to 1/2 out of 200. Question 15, we could skip 15 because it was too difficult. And question 16, our last question, it says, suppose one large square represents 100%. The square is divided into smaller equal-sized pieces. If there are 1,000 pieces, what percent do 17 of those 1,000 represent? Well, the first thing I need to say, if there's 1,000 pieces, then our denominator is 1,000. And our numerator would be 17. That's 17 pieces out of 1,000. That's the fraction. But as a percent, since all percentages are out of 100, to make this equivalent fraction, what do I divide 1,000 by to get 100? 10. So I'd have to divide the numerator by 10 too, and I get 1.7 out of 100. So what percent does that represent? It represents 1.7%. 17 pieces shaded in out of 1,000 represents 1.7%. B, if there are two large squares each divided into 10 smaller pieces. So here we have a picture of two larger squares each divided into 10 smaller pieces. What percent do 13 shaded in and out of that? So if I shaded in this first, this is 10 parts shaded in. And if I was to do 3 more, what percent would this be? Well, right here, we have 10 parts out of 10. And over here, we have 3 parts out of 10. If I was to make that into an equivalent, or add those two fractions together, it would be 13 out of 10, which as a percentage, since percentages are out of 100, would be 130 out of 100, which is equal to what percent? 130%. And finally, our last question says, C, if the large square is divided into 8 smaller pieces. Oh, thank you. So here we have our 8 pieces. Sorry. And the question is, 87.5% is going to be equal to how many of those 8 sections? So 87.5% is represented here by this fraction, is equivalent to how many out of 8? Does anyone know what I divide 100 by to get 8? What is it? It is. So if I divide this by 12.5, I'm going to create this equivalent fraction. And I'm going to divide this by 12.5. And take my calculator. I know the answer, but I'm going to do it for dramatic purposes. 87.5 divided by 12.5 is equal to 7. So therefore, as an equivalent fraction, 87.5% with this new non-hundreds grid shaded in of 8 parts instead of 100, I would have 7 of the 8 shaded in. This would represent 87.5%. 56.25%, if I think of that again, I'll just back this up a bit. So 56.25% or 56.25% out of 100 is equal to how many out of 8? Again, I'm going to divide both by 12.5 here to create this equivalent fraction. And 56.25 or 56.25% divided by 12.5 is equal to 4.5. So here, I would have to shade in 4 of them, and take this last one here, and shade in half of it, and this would be 56.25%.